Let's look at a couple examples of factoring trinomials by grouping, or it's also called, sometimes it's called the AC method. But it's really just factoring by grouping with 3 terms instead of 4 terms. So let's look at our first example. So here we have a trinomial, and we need to split the middle term using two numbers that multiply to be 6 times negative 15. 6 times negative 15 is negative 90. And the two numbers we find need to add to be negative 1, because this is like negative 1 x squared. So let's list the numbers that multiply to be negative 90. Negative 1, positive 90. Negative 2, positive 45. Negative 3, positive 30. Let's see, 4 doesn't go in. 5 goes in 18 times. 6 goes in 15 times. 7 doesn't go in. 8 doesn't go in. 9 goes in 10 times. And then that's it. If we start listing more, we'll start repeating things that we already have. Now, none of these pairs adds up to be negative 1. But negative 9 plus 10 adds to be positive 1. So I'll just change that to be 9 and negative 10. Because 9 times negative 10 is negative 90, and 9 plus negative 10 is negative 1. So I'll choose those two numbers because they also add to be negative 1. So I'll split my term here. I'll leave 6x to the fourth alone. I'll leave negative 15 alone. Let's move this out of the way a little bit. And now I've got to use plus 9 minus 10. And this is where most people get confused in this problem. We're splitting an x squared term. So the two terms that we split it with also have to be x squared terms. That's because if you look at plus 9x squared minus 10x squared, when you add those together, you get negative 1x squared. Okay? So when you split the middle term, the two terms you get have to be the same type of term that you did split. Now we'll finish this by grouping. So I'll group the first two and I'll group the last two. Out of my first two, 3 goes into 6 and 9, and x squared goes into both also. So I'll pull out a 3x squared, leaving behind a 2x squared plus a 3. In my second half, I can pull out a negative because my first term of my second half is negative. So I'll pull out a negative, and 5 goes into both. So I'll pull out negative 5. When I pull out the negative 5, the 10 becomes a positive 2x squared. When I pull negative 5 out of negative 15, that becomes a positive 3. And now, since my 2x squared plus 3 is common to my first half and my second half, I'll pull that common piece out of both, leaving behind 3x squared minus 5. And now we've got it factored. Okay, so the key here is how to split your middle term properly. You have to make sure the two terms that you split with are the same type of term as the term you started with. Here's our second example. It's a little bit different. It's already in descending order and there's no GCF. It is a trinomial, so we'll be looking to split the middle term. But first, we have a negative first term. So the first thing we need to do is factor out the negative 1, because 1 is the biggest thing that goes into all three. So we pull out a negative 1, which is going to make this positive k squared, positive 7k, positive 10. So pulling out the negative 1 just changes all your signs. Now we have this trinomial that we need to factor. So I'll go off and do that on the side here. We know when we factor this, it's going to be negative 1 times two binomials like this. So we have to figure out what binomials to use, and I'm going to figure that out on the side work over here. So I've got k squared plus 7k, not x, sorry, plus 7k plus 10. So I need two numbers that multiply to be 1 times 10. Well, that's 10. So let's list all the numbers that multiply to be 10. 1 times 10, 2 times 5, and that's it. I need to find a pair of numbers from that list that adds to be 7. So these are the numbers we'll use because they add to 7. So I'll split my 7k. So I've got k squared and I've got my plus 10. And because this is a k term, both of the middle terms we have here will be k terms. So I'll have plus 2k and plus 5k. Then we use grouping on both halves. In my first half, I can pull out a k, leaving behind k plus 2. And my first term in my second half is positive, so I'll pull out positive 5, also leaving k plus 2. And then finally, in my first half and my second half, I can see that I've got a k plus 2 in common that I'll pull out, leaving behind the k plus 5. So now I've factored the trinomial, so I need to bring it back over and put it in here to be k plus 2, k plus 5, and we're done. So I like to get the GCF out and maybe work on the trinomial on the side so that I don't mix my GCF into this mess over here. You don't have to do it that way, but I found in particular for students learning this for the first time, it's useful to separate the GCF from the trinomial part, and this is a good way to do that.